Now we are going to see what is a linked list and how we can use linked list in Java, and what are the real-time examples of linked list. So before proceeding to linked list, we would try to relate linked list with the train compartment example. For example, if suppose if there is a train with 12 compartments, each compartment is linked to another compartment using some chain. So that is called the real-time example of linked list. So in linked list, each element is linked to another element using some link. Technically, it's called pointing address, whereas in the real-time example, it's called some link, chain link, like that. So internally, linked list uses doubly linked list data structure. I have already talked about the doubly linked data structure in the data structure videos. Suppose if you haven't watched, please watch that double linked list data structure video and then come to this video. Otherwise, you can just Google what is a double linked list data structure. Anyway, I will give brief info about the double linked data structure. Double linked data structure example, the same example, the train example. Here, each compartment has two links at the front end and at the back end. At the front, the link that is present in the front end is used to connect the compartment that is present before that compartment. And similarly, the link that is present at the backside is used to connect the compartment at the back end. So we will see the usage of the double linked list in the further videos. And then linked list is used for adding and removing a tail. For example, you can add 4 or 5 compartments easily at the end of the existing compartment, at the end of the last compartment. So if your train has 12 compartments, you can easily insert the 30th compartment at the end of the 12th compartment. So if you want to remove the 12th compartments, you can easily remove 12th compartment without touching the other compartments. That's the power of linked list. So now we will see what are the differences between the array list and linked list. In the previous video, I have already talked about the array list and how we can use array list in Java. If you haven't watched, please watch that video and come to this video. What are the differences between array list and linked list? Array list internally uses dynamic arrays to store elements. So we can treat this as a apartment. If apartment has 10 floors, if you are residing at the 0th floor, your parents are residing at the 1st floor, and your cousins are residing at 2nd floor, etc. So this is similar to that. So each floor is called an index technically. So you can easily point the actual data that is present in the index. So it's very easy to retrieve the data. That's the power of array list. Whereas in linked list, that's not the case, because linked list don't have some specific index. Linked list elements are spread across the memory, so it can be present besides you, it can be present very far from the current element, like that. So the retrieving process is very slow in the linked list because you don't know the index where the element is actually present. So since it is spread across the memory, it can't easily retrieve. Whereas in array list, the elements are present at the successive blocks. And manipulation in array list is slow because it internally uses array. If any element is, we will consider an example. So if you arrange the books in an order, so first book, and on the first book you have kept the second book, on the second book we have kept the third book, like that. So if you want to remove 5th book from the 10 books, what we will do, you will first remove the 5th book, and then automatically the 6th book moves to the 5th book position, 7th book moves to the 6th book position, like that. So here the operation is very costly. So the books that are present above the 5th book needs to move from its original position to one position backwards. Whereas in linked list, that's not the case, because in linked list the books are placed across the table. So example, first book are placed on the one end of the table and the second book is placed at the other end of the table. Okay, so you can easily remove the books that are present on the table but distributed across the table. That's why manipulation linked list is very fast when compared to addList. And then addList is better for storing and accessing data. So I have already talked about the out. Since we know the index, we can easily point to that element. Whereas in linked list, we don't have that index. So we need to iterate each book or each element to reach the final element. So these are the major differences. So actually, in code wise, the only difference is in the previous video I have used addList here in these two places, whereas here I have used inklist. Otherwise the code remains the same. The internal things are the technical things differs. If we run this code, you would see the following output, because first we have added C, then C++, and then C++ Java. So here I am just summarizing the information, summarizing out why we got this output. If you want to see in detail, please go and watch the addList video and then come to this video. So C++, C++, Java, and then what we are trying to do is we are adding one at the first position Python. So C, Python, C++, Java, and then what we are trying to do, we are trying to remove C. So then Python, C++, Java. So please go and watch addList video and then come to this LinkedList video for getting more information and detailed information.